So the final transformation that we're going to talk about is going to be rotations on the coordinate plane. It's actually my least favorite transformation to do. Some of you might find it pretty easy. I think it's the hardest one to look at. But I also have a difficult time or a hard time visualizing those movements, either rotation that's clockwise or counterclockwise. So some of you might find this a little bit easier. I think it's the hardest transformation. So a rotation is a transformation in which a figure is turned around some sort of a fixed point. This point is called the center of rotation, and rotations are also called turns, kind of like when we talked about translations, and those were slides. When we talked about reflections, we also called those flips. Since a rotated image and its original figure have the same size and shape, they are congruent, so same size, same shape. We can have rotations that are clockwise, which will be going sort of around to the right, or counterclockwise, which is going around towards the left. So those are demonstrated here. So the images below show clockwise rotations of a figure with the center of rotation at point A. So we've got our original figure. It kind of looks like a little flag here, and we're going to rotate it around point A 90 degrees clockwise. So that's going to be going towards the right. What you see is this vertical line right here above A is going to be rotated 90 degrees sort of to the right here. So basically it's going to form a right angle with where it used to be. So it was about 1.5 units up. Now it's going to be 1.5 units to the right. And then we just kind of copy that image over so you can see it here. So this, like the pole part of the flag was vertical. Once we rotate it 90 degrees clockwise, it's going to become horizontal. So we can also take that original image and rotate it 180 degrees clockwise, and that's going to actually force it to be upside down. And you can kind of envision, and you could even take your paper and just flip your paper upside down, which would be 180 degrees rotation clockwise. And that would give you an idea of what it looks like. It's a little harder than to graph it on the coordinate plane, but we can also do that. And then 270 degrees clockwise is actually going to be 90 degrees short of a full rotation. So you could also rotate it 90 degrees counterclockwise. So if you take your original figure and then take this guy and rotate it 90 degrees counterclockwise, that would also be the same as 270 degrees clockwise. And I think we'll see that in one of our later examples. So that's it for that first page of the notes. Just a bunch of pictures and a bunch of examples. What I can tell you is that there's not a ton of questions on rotations on your test or on your quiz for this, or even on the unit test, because it is one of those harder transformations to work with. It's something that you'll see more of when you take algebra, and you'll also see more of it in the geometry course as well. So let's go ahead and take a look at problem number 1, where it says, draw the figure after a 90 degrees clockwise rotation about point M. So if we're going to rotate this thing 90 degrees clockwise, you can actually see this one's done for us. M prime is your new point M. But like what I did was I copied this figure, and I want to show you a 90 degree clockwise rotation. I can actually take this image and just rotate it like this 90 degrees. And it's going to end up looking like this, which is how we get this figure over here. Obviously, the M also rotated with it, so we would just want to replace it with M prime. It's basically taking each of these segments and making them 90 degrees from where they were. Again, rotating that clockwise, which is towards the right. So it's kind of hard to visualize. We're going to take a look at our next example here, where we actually have to construct the figure. So number 2 asks us, and you can see it's already done for us, and we'll talk through this. It asks us to draw the figure after a 180 degrees clockwise rotation about point J, and then also after a 90 degrees counterclockwise rotation about point J. So again, if we're taking this figure and we're rotating it at 180 degrees clockwise, it's basically going to flip it upside down. So if this is our figure here, 90 degrees clockwise is going to be to the right, 90 degrees. But we have to take it a full rotation, so this green dot is going to be facing down. So it's going to look like this, except obviously we need to flip that J around to make it J prime, but it's going to be upside down. It's kind of hard to sketch, but again, if you flip your paper and then draw that picture of what it looks like when you flip your paper upside down, that's what our 180 degrees clockwise rotation is going to look like. And again, if we have technology, which is nice, we can copy and paste that picture and just rotate it like this, which is how I came up with these figures here. Now, if we go back to our original figure, we now want to rotate it 90 degrees counterclockwise. So that's going towards the left. So remember, that's only going to go where this green dot's going to go to the left. And it's going to look like this. So each of these segments is going to rotate 90 degrees, sort of going in a downwards or left direction. And it's going to look like this. So you may want to pause the video so you can at least copy those pictures down so you have them. Some of you, like I said, are going to be really good at visualizing this and being like, yep, that's what it looks like. Others are going to struggle a bit. That's me. I'm not really good with, you know, when you do like a top view, side view, front view, back view of some sort of shape. This is kind of like that, where it's a little tricky to visualize. So hopefully when I go through this video, it makes somewhat of sense. But recognize that it is one of those topics that I find a little harder. So it's also a little harder for me to explain. All right, so number 3 is done for us, but I do want to talk through this. So it says quadrilateral WXYZ has vertices W at -4, -1, X at -2, 0, Y at -3, -1, and Z at -1, -4. We want to graph the figure and its image after a clockwise rotation of 180 degrees about vertex X. So we can also rotate around the origin, which we'll see. But we're also going to give the coordinates of the vertices for quadrilateral W prime, X prime, Y prime, and Z prime. So the first thing we did was graph the original figure. And we actually started, X is going to stay where it is since we're rotating it around X. So now we're going to rotate point W 180 degrees. So you can see that we did that there. Basically, it's going to go in the opposite direction. So kind of like you had to go down 1 and left 2 to get to W. Now you're going to go up 1 and right 2 to get to W prime. Now, step 3, we're going to graph those remaining vertices so you can see that we did that. We took Y to Y prime. Again, we went down 3, right 1. Now we're going to go up 3, left 1, sort of going in those opposite directions. And then Z prime is actually directly below X, or sorry, Z is directly below X. So 1, 2, 3, 4 units. Now it's going to be 4 units above X to get our Z prime. And so we can graph that here. Again, some of you, this is going to come forth right away, easy to visualize. Others, it's going to be a little trickier. Once we've graphed those coordinates, then we can list those coordinates out. So keep in mind, since we rotated around X, X and X prime are the same, and then W prime was at 0, 1, X prime was at -2, 0, where it was before, Y prime is at -3, 3, and Z prime is at -2, 4. So let's try one of these. So we've got triangle ABC has vertices of A at 2, 1, B at 1, -1, and C at 4, -1. And you can see I already graphed and labeled them on the coordinate plane here. We want to graph the figure, which we did, and its image after a clockwise rotation of 90 degrees about vertex B. Then we'll give the coordinates of the vertices for A prime, B prime, C prime. Okay, so B is going to stay where it is, but C is going to move right now. Again, we're going clockwise, so that's kind of towards the right, 90 degrees. So where we had, I'm going to go ahead and get a different color here. Where we had C being 1, 2, 3 units to the right of B, it's now going to be 3 units down. So 1, 2, 3 units down. And let me move this out of the way. So that's where our C prime is going to be. So B and B prime are in the same position here. So this is B and B prime. And then just move that out of the way here. And then C prime is going to be down here. Again, we rotated it. You can see that's a 90-degree angle from where it was. So again, it's going to be down 3 units. Now, A is a little trickier, but from B, we went right 1 up 2. So as we rotate this thing 90 degrees, we are going to have a line that sort of looks like this. Okay, and you can actually imagine taking this sort of as like a right triangle. Let me go ahead and sketch this in for us. So what I kind of envision, I'm going to do this in blue, we'll do a different color. If I make like a right triangle between points B and A, since we're rotating around B and we're rotating that point A, I'm going to imagine rotating this triangle down. So it's now going to be over here, and it's going to look sort of like this when we rotate it 90 degrees. And we know that that point A is going to just follow right down, bloop, bloop, bloop. And point A prime is going to be right down here. So I'm going to erase these triangles. But again, I rotated this blue triangle down 90 degrees, and that basically told us where A prime was going to be located here. And then we'll go ahead and connect them here in a moment. But let me delete these blue lines so they don't get too confusing having those in. Maybe it'll let me delete them. Oh, don't delete the entire picture. Let's go with that. All right, delete that line. There we go. And I apologize, that takes a few moments to delete, but I think sometimes it helps. Making like a right triangle is a little bit easier to visualize. And let me go ahead and label that point as our A prime and connect those with red lines just to separate it here. So let me grab my line tool, and here we go. And so our triangle is going to look like this. So this is if I took this triangle and rotated it 90 degrees clockwise. So A prime is going to be located at 3, -2, as we can see right there. B prime is going to be in that same position, 1, -1, and then C prime is at 1, -4. And again, sometimes it helps making those right triangles to help us rotate it. All right, let's go ahead and take a look at some of the other things that we have here. We're going to also rotate around the origin. And I just want you to keep in mind, if you're like, oh, this is really hard to visualize, that's okay. You're not going to have a lot of questions on this on a quiz or a test or anything like that. So rotating a figure about the origin means using 0, 0 as the center of rotation rather than one of the points. So the diagrams below show 3 clockwise rotations of a figure about the origin. So where we're rotating this, we've got our original triangle in blue, and then we're rotating it 90 degrees about the origin, which means none of your points stay in the same position. And we'll talk about kind of making some little triangles to rotate those. So you can see I rotated this clockwise down that way. The 180 degrees rotation, again, about the origin, not about a point, actually goes from being in that first quadrant to the third quadrant and looks the same, but now it's upside down. And then a 270 degrees clockwise rotation, again, is the same as a 90 degrees counterclockwise rotation. The diagrams below show 3 counterclockwise rotations about the origin, so original figures in blue. Keep in mind that 90 degrees counterclockwise, or sorry, 270 degrees. Oh, looks like, actually, sorry, the green is our original figure this time. I'm not sure exactly why they started with green this time. But our green figure looks like we are rotating counterclockwise 270 degrees. That's the same as a 90 degrees clockwise rotation. So that picture should look kind of familiar to the top right that we had up here. And then we have a 180 degrees rotation, again, counterclockwise. So it goes from being in quadrant 3 to being in quadrant 1. And then our 90 degrees rotation counterclockwise is going from quadrant 4 back up to quadrant 1 there. And again, for whatever reason, they chose to map from the green to the blue this time. Not sure why they switched that. All right, let's go ahead and take a look at example 5 that is done for us. So it says a triangle has vertices A at 2, -5, B at 4, -4, and C at 2, -1. Graph the triangle and its image after a rotation of 270 degrees clockwise about the origin. Then give the coordinates of the vertices for triangle A prime, B prime, C prime. So the first thing we want to do is graph the original figure. That's in blue. We went back to blue this time. A 270 degrees clockwise rotation is actually going to be the same as a 90 degrees counterclockwise rotation. So you can kind of see when I'm rotating point C, I'm going from the origin and I'm going to create a 90 degree angle there, or 270 degrees going around clockwise, but it could be a 90 degrees counterclockwise rotation. So you can see this is 90 degrees here. So instead of being right 2 down 1, now we're up 2 right 1. Now we can graph all the other vertices there. So again, imagining taking these 90 degrees counterclockwise is going to look like this. And we'll actually look at the picture here. What I usually like to do is make those right angles between the point that we are rotating and the origin, which is our point of rotation. So the coordinates of the vertices of A prime are 5, 2, B prime is 4, 4, and C prime is at 1, 2. All right, so let's try one of these examples. So we've got parallelogram ABCD, vertices at -3, -1, B at 1, -2, C at -1, -4, and D at -5, -3. And you can see that I graphed that here. We are going to rotate this thing 180 degrees clockwise, which is like to the right, about the origin. So all of the points are going to change. So this is where it gets a little bit tricky here. So why don't we start with point A? And I'm going to make a right triangle again here, and I'm going to rotate that thing 180 degrees. So if this is my right triangle here, if I rotate it 90 degrees, this segment right here is going to be 3 units up. If I rotate it 180 degrees, it's going to be 3 units to the right. So it's going to be 3 units to the right. I'm going to be up here 1, and then I'm going to have this triangle here. Again, it's like taking this triangle, rotating it 180 degrees. That's going to force A prime to be right up here at 3, 1. I have to move where these points are located, but that's where A prime is going to be located. Now I'm going to delete, excuse me, I'm going to delete all of these blue lines as well as we go to work through this. All right, so let's delete all these blue lines. All right, so next let's go ahead and rotate point B. So I'm going to form a right triangle here. I want to make that in blue. Make sure I have the blue segment. Okay. And we can make our right triangle in lots of different ways here. So here's how I made my right triangle, and we're going to rotate this thing clockwise 180 degrees. So if I were to rotate this 90 degrees clockwise, then this point right here would be 2 units to the left. Now it's going to be 2 units up, and we're going to go out 1 this direction, and then we're going to be like this. So it's going to look kind of like this. And that means that point B is going to be located right here, and that's going to be at -1, 2. So this will be B prime's location. And again, that's going to be at -1, 2. Let me go ahead and delete these blue lines. I know that takes a few moments, but I think it's just the easiest way to kind of visualize what this looks like. Because again, I have a hard time seeing that point move. But if I can move that right triangle, those straight lines, although all lines are straight, just makes life a little bit easier for me. So let's go ahead and take a look at C. So we'll go ahead and make another right triangle here with point C. And we'll make it like this. Why not? Let me actually move this line this way. I think that's a little bit easier to visualize if I move the right lines. Gotta love trying to do this on a laptop and all that good stuff. Okay. Make that blue. All right, so now we're gonna rotate this thing 180 degrees, again, clockwise this direction. So if I were to rotate it 90 degrees, this little segment right here would be up here, and this guy would be going out this way. But I'm going to rotate it 180 degrees. So let me make sure I have the right color here. This segment, which went out this direction, is going to be going the opposite direction. And then this segment, which is 1, 2, 3, 4 units down, is going to be 4 units up. So it's going to be 4 units up, and then this guy is going to go right over here, and that means point C is going to be located right here. So this is going to become C prime, and that's located at 1, 4. Go ahead and reveal that. delete my blue lines. Hopefully it doesn't take too long. It's getting a little bit faster. There we go. And then finally we need to rotate point D. It lets me delete all of these guys. You might hear me hitting the delete button, which sometimes reacts, sometimes does not. So D, let's go ahead and make a right triangle here. Make sure we get the right color. All right. It's as good as it's going to get. So we rotate this thing 90 degrees, and this segment right here is going to be up here by 1, 2, 3, 4, 5 units. Now it's going to be 5 units this direction. And this segment here, which is 3 units down, is going to be 3 units up. And our diagonal just follows through, which means point D, when we map it onto D prime, is going to be right over here. Excuse me. Got like a little bit of congestion going on right now. So keep clearing my throat every now and then just to get that clear. And so that means D prime is going to be at 5, 3, 1, 2, 3, 4, 5, up 3. Good. We'll delete these blue lines, and then we'll connect to form our new parallelogram. And you can always, if you're doing this in pencil, just be erasing the lines as you go, which is what I did on my answer key as I was kind of working through that. I'll go ahead and connect these. We'll do this in red to form our new parallelogram that has been rotated 180 degrees clockwise. All right, it's going to look just like this. All right, let's go ahead and take a look at the last part of this lesson. Again, I want to stress to you there's not a lot of this on the test, so if you're like, oh, this is really tricky, it absolutely is. And we're going to stick with pretty easy rotations, either like 90 degrees about a point or about the origin, or 180 degrees, because that 270 degrees can get a little tricky. So for rotational symmetry, this is if a figure can be rotated less than 360 degrees about its center so that the image matches the original figure. We say that the figure has rotational symmetry. So lots of different shapes in real life have rotational symmetry. In fact, all 3 that are down below do have rotational symmetry, and we'll talk about that. So we're going to determine if it has rotational symmetry. They all do. And we're going to describe the angle of rotation. So number 7 is a snowflake, which we are well past at this point. It definitely has rotational symmetry. If you can rotate it and we end up getting the same shape once we rotate it either clockwise or counterclockwise, which we will here, we can see it can match itself in 6 different positions, which is the number of little spires coming out of the snowflake or the center of the snowflake. What we do to find the angle of rotation, I should say of rotation, we take 360 degrees, which is a full circle, and divide it by the number of positions in which it can match itself, which is 6. 360 divided by 6 is 60 degrees. So when you rotate it 60 degrees, it's going to match itself. So this flower petal is going to have a rotational symmetry to it, and it's going to match itself in 3 positions. 1, 2, 3, the number of petals. So we take 360 divided by 3, and the angle of rotation will be 120 degrees. Finally, we have our star, and that's going to match itself in 5 different positions. So we take 360 divided by 5. That's 72 degrees, so our angle of rotation is 72 degrees. Again, I want to stress to you not to panic too much about these kinds of problems. These are tough, even for myself, which again is why I make those right triangles, rotate the right triangles to help me find where those points are. Not a lot of it on your quiz or test or anything like that. But it is something to be familiar with, and it's something you will go more in depth into, again, in those later courses, including algebra and geometry. Thanks for listening, even though this is a really tough lesson.